David Stringer. Welcome to R-2000, the Better Built House. This is a pretty unique unit behind me. It not only supplies all of the heating and ventilation requirements of this house, but it also supplies most of the domestic hot water. Now, up to this point, we've been concentrating on providing the heating and ventilation requirements of energy-efficient houses. But another important component of the mechanical systems is the hot water tank. See, it's often presumed that the hot water system in one of these houses isn't that important. But it's not uncommon to discover that the fuel consumption to create domestic hot water exceeds the fuel consumption for all of the space heating. So in this program, we're going to look at hot water systems. We're also going to look at some integrated systems, some smaller and more efficient packages. Now, you need a different approach to the house mechanicals because of the higher insulation levels and the controlled air leakage in the Better Built House. Here's a quick review.
Because of its reduced heating requirements, the Better Built House will be able to use smaller heating equipment. The space and water heating equipment is either induced draft, sealed combustion, or condensing equipment because of the tighter envelope and concerns about air quality. And to ensure good air quality, the Better Built House will have a continuously operating mechanical ventilation system.
Now, Oliver Drerup has been with us throughout the entire series because he's an experienced R-2000 builder. And look, there he is now.
Hi, David. This is a pretty unique system, an integrated system. Before we start talking about these units, I'd really like to show you a standard system and the plumbing that goes with it, and we've got one right across the road.
Across the road.
Well, David, what we're looking at here are domestic hot water systems, DHW systems. And as in the other areas that we've looked at, like furnaces, we have the same concerns, health and safety issues. So wherever you're combusting a fuel inside the house, you have to ensure that the thing is vented properly.
So does that mean we're going to be seeing sealed combustion units and induced draft combustion units and condensing units?
Essentially, yes, but you won't find any condensing units because they're just not available. We're going to be looking at induced draft and sealed combustion. This one is induced draft.
Okay, I see that there's a little fan in there, but what's it doing and what's happening?
Okay, well, in essence, you're looking at one half of the system here. An induced draft system draws air in from the room through this blower, out this duct to the exterior. And you can tell we're looking at an efficient unit here because you can see that the duct size is very small, but it's not going into a chimney, but is just venting through the side of a house.
Okay, so induced draft, that blower is just pulling air up and making sure that the thing can't backdraft.
Correct. Now, but that air is being supplied to the unit through a little duct that's being delivered close to the location.
Okay, just close to the unit. Now, in a sealed combustion, you deliver it right to the unit. Is that it?
That duct becomes a part of the unit. So we then have the other half of the system as part of the unit with a duct coming into it, going through the combustion process, and then passing directly back outside.
Okay, so we've got efficient combustion that can't backdraft. Is there anything else energy clever about this?
Well, you've got to look at the insulation levels on the tank itself. You'll find that most manufacturers, if not all, have a high efficiency unit for their domestic hot water, which generally means that it has higher levels of insulation around it. The homeowner or builder can also improve their system by putting additional insulation, for example, underneath the tank, between the tank and the concrete slab, and also by insulating the piping inside the house, because you're losing heat from that piping to the house itself.
Well, now, why are you being so picky here? If you lose heat from this tank, you're gaining it in the house, right?
Fair enough, and that's okay in the wintertime. You have a higher domestic hot water bill and a lower space heating bill, but in the summertime, especially in these energy-conserving houses, you don't want that source of heat. So what we're using is conventional pipe insulation for, say, 3-4 feet on the end of the tank. Alternatively, some guys put an S-trap in here to prevent the thermosiphoning, or you can insulate the whole system.
Now, would things like that apply to an electric tank as well, those little extra savings?
Certainly do. You'll also find electric tanks with higher levels of insulation, but of course the electric tanks don't have any of these combustion issues related to them because they're closed, they're completely sealed. I think you'll find that in the industry, the trend is toward more and more integrated systems, and I wish I could show them to you, but unfortunately I don't think we have the time.
Well, that's okay, actually, because we've assembled some shots of the more interesting ones, and I think we will get to take a look at them.
Here are some shots of equipment which provide hot water as part of the house heating system. There are a couple of variations on this theme. This is a forced air furnace, but with a twist. A heat transfer material of glycol and water flows from the combustion chamber of the furnace into a copper heat exchanger inside this insulated tank. The heat is then transferred to the water storage tank. Now, we've already seen the hydropulse boiler. In this system, the water which is heated in the boiler is circulated through the DHW tank where the heat is stored, then distributed throughout the house as required. Now this system here combines heat pump technology with the supply of hot water. Besides providing hot water, the heat pump can be used to assist in space cooling and in the dehumidification of the house. The heat pump extracts heat from the surrounding air and puts it into the hot water tank.
That's quite a variety of options, and it seems like everything is kind of channeling itself towards the idea of integrated systems. Why is that?
Well, it's really, I think, the trend in the industry at the moment. What you've got to realize is that there are three separate aspects of the thing which really make life easier for the builder. The first is that you don't have to service the house in the way in which we have before. We have gas services, electric services, water services, all this stuff coming into the building. We may be able to reduce or at least combine those things so we don't have ditches running all over our developments. The second thing is that instead of having all these various pieces of mechanical equipment in the building, we just bring in a single box and put it down in the basement. Wherever you want, connect it, plug it in, and away you go. And finally, there's a great deal of efficiency that can be obtained from the various systems in the house knowing about one another, because it means that the systems will be able to rob heat from one process for another process, depending on the seasonal requirements of the building.
Sort of, if we wanted to be philosophical, we'd say that was a marriage of the components or something. I guess that's precisely what it is. So when do we get to see these great magic boxes? When can we go out and buy them?
Well, the majority of the major manufacturers in the mechanical business have entered the field now, and all either have prototypes or operating units. We're going to be seeing a lot of them.
Now, I was standing in front of one at the beginning of the program, which I guess is a pretty new unit, unique. And as you know, I'm very captivated with anything that has a lot of blinking lights and controls on it, and I'm dying to see inside. When do we get to have a close look at the guts of one?
Well, while I've been teaching you about housing, you've been teaching me a lot about TV, so I'm afraid it's too late, because I've already stolen the crew and gone and shot it. And here it is. I'm here with Larry Miller, a friend of mine from Fiberglass Canada, who's going to be telling us about the Habitaire unit. Hi, Larry.
Morning, Oliver. I'm glad you can make it out today.
Nice to be here. You guys tout this unit as being able to do just about everything except make your morning coffee. Can you explain to us how it works?
Well, Oliver, let me start off by saying that we found this product in Sweden, where it's been used for about the last 10 years. It operates much like other heat recovery ventilators that are used in low-energy houses. Stale air is brought into the unit from kitchens and bathrooms. The heat is taken from that air and is transferred to a large self-contained hot water tank. It holds about 50 gallons of water. That heat can be used to wash clothes and wash dishes, but also to help space heat the house.
I see. What's the unit that I'm leaning on?
Well, in the summertime, this equipment offers the added bonus of being able to reverse the duct flows so that the unit can be used to provide some level of air conditioning.
Okay. So far, Larry, we've been talking about exhaust air, that side of the equation. What are you doing to supply air to the house?
Very perceptive of you, Oliver. This house is a little bit different than other low-energy houses in that there is no dedicated fresh air supply. In this house, the builder put a lot of effort on sealing up the major leaks, but we're relying on the minor imperfections in the building to be our source of fresh air. In other words, there's controlled leakage.
So far in the series, we've been stressing the importance of balanced airflows. Is this a balanced system?
Yes, it is. We are exhausting about 150 cubic feet a minute of air from the unit, from the house. As a result, the same quantity of air is leaking into the house. What's different from this and from other houses is that we have an exhaust-only system, so there is a slight negative pressure.
How can we find out more about this kind of unit?
Fiberglass Canada is working closely with the Canadian Home Builders Association to monitor the performance of these houses using our new system, and we will be working with them to educate builders throughout Canada on the availability and benefits of this approach.
That's a very, very interesting way to go about it. I'm going to be looking forward to keeping up with that. I have to go out and look at a whole bunch of wood heating options for R-2000 houses, and time is unfortunately very short, so I'm going to have to say goodbye. Thanks a lot.
My pleasure, Oliver.
So this is what you've been doing.
Yeah, well, I'm not so much nervous that you caught me relaxing. I'm nervous that you caught me relaxing next to a fireplace, because from some snide comments here and there, I gather you don't like fireplaces much, do you?
Well, if you compare this technology to the technology I've just been looking at, the Habitaire unit, integrated systems, that kind of thing, this is an incredibly primitive way to do this job.
So why do you put them in your houses?
It's a real estate issue. People like them, and clients should get what they want.
Okay. Now, is this an unnatural fear of fireplaces you have, or do you have reasons that you don't like them?
No, I have a couple of very specific reasons. The first is that they're fuel inefficient. They burn fuel from 5 to 20% efficiency at best, and that's not very good. The second is that they really are difficult to install in an airtight house because you have to be very careful about detailing the vapor barrier around this heat source. And then you got to realize that they use room air, which you're paying to heat, for both combustion and draft. So they're withdrawing heat from your home all the time.
Okay, well, I guess you've just convinced me as usual. But since you have to put them in, what are the kinds of things you can do to make the situation better?
Two things in specific. The first is that you must bring combustion air into the unit from outside, and it must be direct ducted so that you're never going to have to worry about the combustion taking place using house air. And the second thing is that you should find the tightest fitting doors you possibly can, although I haven't seen many that really fit very well.
Well, give us something to quest for. But you're saying it boils down to everything else in the R-2000 homes. You're looking for quality units with very proper, strict installation.
That's right, and there are really health and safety issues in this case. And I think that anyone buying a home would like to know that their builder has thought about those issues and done something to ensure health and safety in this context. It's really another example of how these houses are better built houses. Well, David, over the last 5 programs, we've been looking at mechanical systems in R-2000 houses. I wonder if you could summarize what we've seen.
Summarize 5 shows?
Try it.
What the heck? I guess it starts with health and safety issues. So the cornerstone of the R-2000 house is the mechanical ventilation system. That system has to use balanced airflows, and it not only has to provide the minimum fresh air requirements for the house, but it also has to provide the proper comfort levels for the people that are in the house. Then things start to happen when you start tightening that building envelope and getting rid of leaks. The implications are to the heating equipment in the house. So you use higher efficiency equipment, but more importantly, you use equipment that's designed not to backdraft under any circumstances. And I guess a general rule is anything that has combustion in the house has its own source of external combustion air. You bring it in with its own duct just for that unit. Then we looked at the advantages of integrating some of the house mechanical systems just to save money and also to make installation easier. And I guess it starts with health and safety, and the issues continue on to good design and proper installation techniques of the equipment.
I'm really impressed. I think maybe we could have done away with some of those shows.
I just did 5 shows, didn't I?
You did. Nice summary. Here's an issue that I want to stress. This business of health and safety is true not only in R-2000 houses, it's true of all houses. The thing that the consumer knows when they look at an R-2000 house is that the builder has been trained to identify those areas where problems might arise and has dealt with them. And I think that that's really a very valuable thing from the consumer's point of view. What we're going to be doing next week is looking at the way in which some of these changes affect the tradespeople working on the site, and I think it's going to be really interesting.
Never forget the people who actually have to build the houses. Sounds interesting. So join us next time on R-2000, the Better Built House.